I would like to recall, here is the sine hyperbolic x and here is the cosine hyperbolic x. And from here we get the tangent hyperbolic function, the cotangent hyperbolic function, the secant hyperbolic function, and the cosecant hyperbolic function. We will start with the derivative of sine hyperbolic x. This is cosine hyperbolic x. d dx of cosine hyperbolic x is sine hyperbolic x. d dx of tangent hyperbolic x is secant hyperbolic x to the power of 2. And d dx of secant hyperbolic x is negative secant hyperbolic x times tangent hyperbolic x. d dx of cotangent hyperbolic x is negative cosecant hyperbolic x to the power of 2. And d dx of cosecant hyperbolic x is negative cosecant hyperbolic x times cotangent hyperbolic x. It is easy to get the derivatives of whole hyperbolic functions using the chain and the quotient rule for derivatives. For example, let's find the derivative of sine hyperbolic x and of secant hyperbolic x. d dx of sine hyperbolic x is exactly d dx of e to the x minus e to the negative x over 2. We will use chain rule for the second one and we get e to the x minus e to the negative x over 2, which is just e to the x plus e to the minus x over 2, which is cosine hyperbolic of x. Now let's try to find the derivative of the secant hyperbolic x by writing what is the secant hyperbolic x. It is 2 over e to the x plus e to the negative x. We'll use the quotient rule and we will get this. It really doesn't look like the answer, so let's work it out a little bit. First of all, I distribute the negative. Now I just split it to the product of two things. The first one is e to the x minus e to the negative x over e to the x plus e to the negative x, and the second one, it's 2 over e to the x plus e to the negative x. And if you can recognize, the first one is tangent hyperbolic x and the second one is secant hyperbolic x. And also don't forget the minus. Here is a summary: the derivatives of some hyperbolic functions versus trigonometric functions, because they're very similar, but they might be a change with the sign. Sometimes we have minus in one and not in the other. This is such example. With the hyperbolic we don't have minus, with the trigonometric we do. And here's another one. Here we have minus in the hyperbolic, but we do not have minus in the trigonometric. Examples. Let's differentiate sine hyperbolic of x to the power of 2 plus x. It is cosine hyperbolic of x to the power of 2 plus x times 2x plus 1 because of the chain rule. Another example. Let's differentiate tangent hyperbolic x to the power of 2. We have to use the chain rule. First we get 2 tangent hyperbolic x, and then we have to differentiate the inner function, which is the tangent hyperbolic x. And we get this. Another example. Let's differentiate the square root of cosine hyperbolic x. Please recall the d of square root of u is 1 over 2 times square root of u. The outer function is the square root function, so we get 1 over 2 times square root of cosine hyperbolic x, but by the chain rule we also have to multiply by the derivative of the inner function, and we get this. Now we are going to evaluate the derivative of sine hyperbolic x over e to the x twice, directly, and also by using the fact that the sine hyperbolic x is e to the x minus e to the minus x over 2. First, we are doing this by using the quotient rule. We can simplify, we can cancel e to the x, as you can see. And we get cosine hyperbolic x minus sine hyperbolic x over e to the x. Let's write it in a different way. Let's substitute now for the cosine hyperbolic x and for the sine hyperbolic x. And you can see that we get a lot of cancellation. So we end up getting 2 times e to the negative x over 2 e to the x. We can cancel the 2. And also we can write e to the negative x as 1 over e to the x. And we get 1 over e to the power of 2x. Now we are going to do it differently. We are going to express sine hyperbolic x first of all as this e to the x minus e to the negative x over 2. So we get that sine hyperbolic x over e to the x is e to the x minus e to the negative x over 2 times e to the x. Now we split it to 2 and we want to differentiate. From the first one we get 1 over 2, and then after simplifying the second part we get negative 1 over 2e to the 2x. We write 1 over e to the 2x as e to the negative 2x. Now we get that the derivative of this is negative 2, using the chain rule, times e to the negative 2x. So everything is negative 1/2 times negative 2 times e to the negative 2x, which is e to the negative 2x, which also can be written as 1 over e to the 2x. Obviously, I got exactly as before. Let's recall some explicit expressions of inverse hyperbolic functions. The inverse of the sine hyperbolic x is also ln of x plus square root of x to the power of 2 plus 1. The inverse for the cosine hyperbolic x is also ln of x plus square root of x to the power of 2 minus 1, but x has to be greater or equals 1. The inverse for the tangent hyperbolic x is half of ln of 1 plus x over 1 minus x, and x is greater than negative 1 and smaller than 1. Let's see derivatives of common inverse hyperbolic functions. We will start by finding the derivative of the inverse function for the cosine hyperbolic x. We will use implicit differentiation. Y equals the inverse of the cosine hyperbolic x if and only if x equals cosine hyperbolic y. I'm going to take implicit differentiation of that. So we need to find d dx of cosine hyperbolic y, which equals d dx of x. And we get that sine hyperbolic y dy dx equals 1. dy dx then is 1 over sine hyperbolic y. We are going to use this to express that as a function of x. We get this. It means that sine hyperbolic y is the square root of cosine hyperbolic to the power of 2 of y minus 1. There is no need to have plus minus in the square root because sine hyperbolic y is non-negative and y is non-negative. But I know that cosine hyperbolic y is x. So I will replace this by x, and I get 1 over square root of x to the power of 2 minus 1. We conclude that the derivative of the inverse for the cosine hyperbolic x is 1 over square root of x to the power of 2 minus 1. Here are the derivative of the inverse hyperbolic functions. We know this one, and we know this one. d dx of the inverse tangent hyperbolic x equals 1 over 1 minus x to the power of 2. And d dx of cotangent hyperbolic x equals also 1 over 1 minus x to the power of 2. Yes? d dx of the inverse secant hyperbolic x equals negative 1 over x times square root of 1 minus x to the power of 2. And d dx of the inverse of the cosecant hyperbolic x equals negative 1 over x in absolute value times square root of 1 plus x to the power of 2. Let's do a few examples. First, we will find the derivative of the inverse sine hyperbolic of x to the power of 2 plus 5x. This is pretty much just a chain rule. And we get this. Another example. Let's find the derivative of ln of the inverse cosine hyperbolic x. Because it's ln to a function, then the answer will be the derivative of the inner function, which is the inverse cosine hyperbolic x, over the function itself, which is the inverse of cosine hyperbolic x. And the derivative of the cosine hyperbolic x inverse is 1 over square root of x to the power of 2 minus 1. We will just rewrite it and we get this.